Okay, so the concept of gradients are pretty important in calculus. So we'll just quickly have a look at what a gradient means. So you should probably know this by now, but we'll just recap this just to be sure. So let's say you have a straight line. The gradient of this straight line is defined as how much it's gone up, and we call that its rise, versus how much it's run. So the gradient here, which we call m, is defined as the rise over run. So if I was to quickly represent what that means, is let's say I have a line here, and this is 4, this is 5, this is another very accurate graph. But let's say this is the kind of line that I have. If I want to find the gradient of this line, firstly I say, okay, what's its run? And that's 4, because that's basically the amount that it has gone over in the x-axis. Okay, and it doesn't matter where you measure it from. So you can just go here, or you can measure it from here, or you can measure it from there. It'll always be the same thing, so, because you're dividing. Okay, so I'm saying that the run of this is 4 and has a rise of 5. So its gradient is basically just rise, which is 5 over 4. Okay? Now we know that a line that's going, any line that's got that shape, it has a positive gradient. If it's on the other way, it's got a negative gradient. Okay? We can also have something like this. So what is the slope of this line? So think about going up a ramp. Okay, so let's say you're here and you're going up a ramp. You can clearly see that this ramp has a slope. Whereas if you're standing here and you want to go up this ramp, well, this is not actually a ramp. This is just a flat surface. Okay, so the gradient here is basically 0. Okay, this line is a straight line and has basically no gradient. And the reason for that is that this actually doesn't have this rise component. Now, effectively, if you think about this doesn't have a rise component, the opposite to that is this line, which is basically a line that goes vertically upward. So the gradient of this line is just undefined. So it doesn't have a gradient. And why is that? It's because you know that its rise, whatever it is, its run is 0. So your m is rise, let's say that's an x. And your run, so the amount that is going in the horizontal direction is 0. And you know that any time that you have something over 0, you have got yourself an undefined or basically infinity. In reality, it's just infinity, which means that this has an infinite slope, which is true. So if you're standing here and want to go up this ramp, you're not going to be able to, okay, because it has infinite slope.